Okay, Jane, here we go. We're trying to find whether this series converges or diverges using the ratio test. And you're having a problem with this portion right here. So over here I've kind of shown you how you set up the ratio test. The limit as n approaches infinity of wherever there's an n, put in an n plus 1. And here's the division by a sub n. And by the way, we've left off the absolute value symbols because these terms will always be positive. I can evaluate this by multiplying the numerator by the reciprocal of the denominator, and normally that's what we just write first. And I separated these into 3 separate fractions so you could see what's canceling out. The limit as n approaches infinity of n plus 1 over n. 9 to the n plus 1 divided by 9 to the n is just 9, because we say n plus 1 minus n. And now here's the key. This n plus 3 factorial means n plus 3 times n plus 2 times n plus 1 times n, and we keep times n minus 1, and we keep going dot 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 all until we get down to 1. But the key is that this part right here can be written as n plus 2 factorial. So I can separate n plus 3 factorial into n plus 3 times n plus 2 factorial. And that means that these cancel out. So your numerator should just be, by the way, I've got 1 over n plus 3. So it's the limit as n approaches infinity of 9 over n plus 1. So this is what you didn't need, this n plus 2, over n times n plus 3. And if you multiply the n times n plus 3 using the distributive property, you get n squared in the denominator, n in the numerator. So the limit will be 0, which is what you have in the rest. So just a question of realizing this n plus 2 should not be there. Okay, so I'm going to end the video. Oh, by the way, I wanted to show you how you can do some of this stuff on Desmos. Like, here's a sum from s sub x is a function, which I've defined with the summation notation from n equals 1 to x of, there's your definition of your nth term, and I can find s sub 1, 1.5, s sub 2, s sub 3, sum 4 terms together, 5 terms together, 100 terms together, I get 700 something. And then another thing you can do is define a sub x as the nth term of the sequence. And I can find the first term, the third term, the 30th term if I want to. But the key is that if I make up a table of 1, 2, 3, 4, 5, 6, 7, see what's happening. Here's the terms of the sequence. When I do the summation, I'm actually adding these terms together. And as you can see, the ratio between one term and the term before it, you can see how it's getting smaller and smaller. Okay, so that's kind of a proof of the ratio test. But I would especially use this first one if I wasn't sure whether a sequence was going to converge or not. Whoop. So it can't go that high. So let's say, see if 500, no, 50. Well, I already did 100. Maybe 300. Okay. So it looks like this series has an upper limit of 700 point something. Not sure what it is, but it definitely converges. Okay, so I'll end the video, and I will also send a link to this Desmos graph in case you want to